Welcome to Understand the Math. In this video, I'm going to teach you how to find the domain and range of an inverse function. We'll start by going over the basics of how to find the domain and range of an inverse function, and then we'll walk through these three example problems. Let's get started. Let's begin by going over some steps that you can follow to find the domain and range of an inverse function. Let's start with a quick review of domain and range. The domain of a function is the set of all possible input values, and then the range of a function is just the set of all possible output values of the function. Let's say we have a function f. We're going to put x into our function, and what we get back out is f of x. X, the values that we put into the function, are our domain, and then the f of x, which is the values that we get out of our function, is just the range. Now let's talk about this in the context of inverse functions. Remember, an inverse function undoes the action of the original function. I have a video on this if you need to review that concept. An inverse function takes the output of the original function, that's this function right here, f of x. You put it into our inverse function, and then our inverse function returns the original input, which is our x value. So for an inverse function, our domain are the values in f of x, and then the range is the x values. I've summarized this down here in this box. The domain of f of x, which is right here, is the same as the range of f inverse. In a similar way, the range of f of x, which is right up here, is the same as the domain of f inverse. Now that we understand how the domain and range of f and f inverse are related, here's some steps that we can follow to find them when we're actually doing a problem. In each problem, we're going to be given a function f of x. The first thing we need to do is find the inverse function. And then once we find the inverse function, we're going to be able to find the domain of the inverse function. And then their third step is we're going to find the domain of the original function because that is the range of the inverse function. Let's now go through some examples so you can see exactly how this works. In our first example, our function f is a rational function. We're asked to find the domain and range of the inverse function of f. Just to make things easier, I wrote down the steps that we just went over on the previous page so we'll know exactly what to do. Our first step is we're going to find the inverse function. In a previous video, I wrote down steps that you can follow to find the inverse of a function. And these steps I went ahead and put right here. So we're going to follow those. I'll make those with a blue so you don't get confused. So our first step to find the inverse function is we're going to replace f of x with y. So looking up above, we have y now is equal, let's pull it down here so you can see it. Y is going to be equal to 2x plus 1, all divided by 2x minus 4. So that's our first step. We're just replacing f of x with y. Our second step is we're going to switch x and y. So wherever we have a y, we're going to put an x, and wherever we have an x, we're going to put a y. Now for our third step, that's the hard part. We have to solve for y. I think it's easier if we go ahead and we put our y's on the left-hand side, so let's do that. So we have 2y plus 1, all divided by 2y minus 4 is equal to x. Now we're going to solve for y. To solve for y, we can multiply both sides of our equation by 2y minus 4. So let's do that. On the left, we have 2y plus 1, and then on the right, we're going to get x times 2y minus 4. Now what we're going to do on the right-hand side is multiply everything out. The left-hand side stays the same, 2y plus 1. And on the right-hand side, we have a 2xy minus 4x. Now we're solving for y, so let's pull our y's to the left and everything else to the right. This gives us 2y minus 2xy. And then the 1 we're going to pull over to the right, and that gives us a minus 4x minus 1. Now we need to solve for y, so let's factor that out. So we have y. This gives us a 2 minus 2x left. And then the right-hand side is the same. What we need to do now is solve for y. So let's divide each side by 2 minus 2x. So we have a minus 4x minus 1, all divided by 2 minus 2x. And that's our answer for y. Now, before we go on to our fourth step, let's notice that we have 3 negatives in our answer for y, and we only have 4 terms. So 3 out of 4 of the terms are negative, which is okay, but it doesn't look as good as if they were positive because positive terms are just easier to work with. So let's do this. Before we go on, let's multiply the top and bottom by minus 1, just to make things looking nicer. So we end up with y is equal to 4x plus 1, and then the terms on the bottom get multiplied by a negative as well. So this gives us 2x minus 2, and that just is a lot easier to work with. The fourth step is we need to replace y with f inverse of x. So we have f inverse of x is equal to 4x plus 1, all divided by 2x minus 2. Okay, now we found the inverse. Now we can go on to our second step. So let me pull this down and let's look at what our second step is. Our second step is to find the domain of the inverse function. Okay, we can do that. We just found our inverse function, so now we just get to find the domain. So we'll mark this as 2. Here's the function that we're looking at, and we need to find the domain. Notice that we can never have a denominator equal to 0, so we're going to have a restriction on our domain, and that restriction is going to be that 2x minus 2 cannot equal 0. And if we solve for x, so we have 2x is not equal to 2, bringing the 2 over to the right, which gives us that x is not equal to 1. So let's write down that the domain of f inverse is going to be all points except 1. So we can write that as minus infinity to 1, union 1 to infinity. So we finished step 2. Now let's go back up to the top and let's look at step 3. Step 3 says find the domain of the original function. So let me go ahead and let's circle this right there. So for the domain of the original function, we're going to have to restrict it so that our denominator cannot be equal to 0. So our denominator is 2x minus 4. Let's keep that in our head. And let's go ahead and write a 3. And then we just found that 2x minus 4 was in our denominator, and that cannot be equal to 0. That was in our original function. So this tells us 2x is not equal to 4, which means x is not equal to 2. So we can say that our domain of f, which is our range of f inverse, which is what we wanted to find, is equal to all points except x is equal to 2. So we can write this as minus infinity to 2, union 2 to infinity. And that's it. Long problem, but we did it. Now, before we go on to our next problem, I want to show you this graph. I went ahead and graphed our inverse function, and that's right up here. This is our graph of y is equal to f inverse of x. I just wanted to show you how the domain and range makes sense when you look at the graph. So notice in this graph that we have an asymptote. I'll highlight it here. We have an asymptote vertical asymptote at x is equal to 1. So that means x is not equal to 1. And notice our domain reflects that. We restricted our value so that x wasn't equal to 1. Now in our graph, we also have a horizontal asymptote. That occurs at y is equal to 2. So that means our range is not going to include any value that's equal to 2, and that's exactly what we came up with. I always like when we look at graphs because it just makes things make more sense. I made this graph on Desmos. It's a free graphing tool. You may want to use it when you're doing these types of problems, just so that you can understand them better. Let's now look at our second example. This example is a quadratic function, and notice we have a restriction on our quadratic function, and it says that x is greater than or equal to 0. The reason for this is this restriction makes our function a one-to-one function. So let's just write that this makes f of x one-to-one. And the reason we need it to be a one-to-one function is only one-to-one functions can have an inverse. What we're asked to do is the same thing we were asked to do in our first example. We're going to find the domain and range of the inverse function of f. I wrote down all the steps again just to make it easier for us. So let's go over here. We're going to start with our first step. Our first step is to find the inverse function. And that actually has 4 steps within it. Our first step is to let f of x be equal to y. So we have y is equal to x squared minus 2. And let's also put that x is greater than or equal to 0. Our second step is to switch x and y. So we have an x on the left, and on the right, we have y squared minus 2. Now, here's where it becomes a little bit tricky, but it's not too bad. Notice that we switched our x and our y. So that means our restriction has to switch, and now our restriction is that y is greater than or equal to 0 because we switched x and y. Let's now go on to our third step. Our third step says we're going to solve for y. So I'm going to go ahead and I'm going to switch both sides of the equation, and I'm going to write my y squared minus 2 on my left and my x on my right. That just makes it easier to solve for y. Now let's do that. We're going to solve for y. I'm going to move the 2 to the right, so we have y squared is equal to x plus 2. Now we're going to take the square root. So y is, remember when you take the square root, you always do plus or minus. So plus or minus the square root of x plus 2. Now, here's where our restriction comes into play. Our restriction tells us that y is greater than or equal to 0. So that means we can only take the positive square root. So let's rewrite this, and let's say that y is just the square root of x plus 2. Now we can go on to step 4, which is just to rewrite y as f inverse of x. So we have f inverse of x is equal to the square root of x plus 2. Now we can go on to step 2, and step 2 is to find the domain of this function that we just calculated. We're going to find the domain of f inverse of x. Notice that f inverse of x is a square root, and we have x plus 2 inside the square root. We can only take the square root of a positive quantity, so we have to say that x plus 2 has to be greater than or equal to 0, which means that x has to be greater than or equal to minus 2. That's our restriction. So now let's write down our domain with this in mind. So our domain of f inverse of x is equal to all numbers greater than or equal to negative 2. So we can write this with a square bracket because it includes negative 2, comma, infinity. We're almost done. Let's now just do our third step. And our third step is to find the domain of the original function. This part was actually already provided to us. Our original function is this, and we were told that x is greater than or equal to 0. That was to make it a one-to-one function. So this part is actually already done for us, and we can just write this down. So we can say that the domain of f of x, which we know is the range of f inverse, is equal to all numbers x greater than or equal to 0. So we're going to write this as 0 to infinity. And that's it. Just like we did with our last example, I want to look at the graphs so that we can just make a little bit more sense of this. This is the graph of f inverse of x. So let's write that this is f inverse of x, which is the square root of x plus 2. So that's what it looks like when you graph it. Notice that our function, we'll highlight it here, starts at -2. Okay, so that's why we have the domain from -2 to infinity. And then also notice that our y value is always positive. And that's why the range is greater than or equal to 0. Let's now go on and do our last example. This example contains a function that is a square root. Just like we did for the last two examples, we're going to find the domain and range of the inverse function of f. You may want to stop the video and see if you can do this one on your own. Our first step is to find the inverse function. And that has 4 steps within it. So that first step then is to replace f of x with y. So we have y is equal to the square root of 2x minus 4. Let's make a note about what y can be. Notice that y is a square root. A square root cannot be negative. So let's make a note that y is greater than or equal to 0. I'm going to highlight that because I honestly think that's one of the hardest parts of this problem, is knowing to write that down. Now let's go on to our second step. Our second step tells us to switch x and y. So we have x is the square root of 2y minus 4, and we can write a restriction for this. X and y switched, so now our restriction is x is greater than or equal to 0. And let's go ahead and we'll highlight that. Our third step is we need to solve for y. I'm going to go ahead and switch sides just like we did for the other examples. I'm going to write the 2y minus 4 with the square root on the left and the x on the right. To get rid of a square root, we're going to have to square each side. So we're going to have our square root of 2y minus 4. We're going to square that. And then we also have to square our right-hand side. On the left, the square root and squaring it cancel each other out. So we just have 2y minus 4 is equal to x squared. Now we can solve for y a little bit easier. Let's move the 4 to the right-hand side. This gives us 2y is equal to x squared plus 4. And then our last step is to just divide by 2. So we get y is x squared plus 4, all divided by 2. And then step 4 is to just replace y with f inverse. So we have f inverse of x is x squared plus 4 divided by 2. What we want to do now is bring along this restriction. So let's put a comma here and say that x has to be greater than or equal to 0. We'll put a star here. That's the hardest part. Now we can go on to our second step. Our second step is to find the domain of this function, this inverse function that we just found. So the domain is this restriction, x is greater than or equal to 0. So let's write down that the domain of f inverse of x is equal to 0 to infinity. Again, that came from having a square root and only being able to have values greater than or equal to 0. Our third step is to find the domain of the original function. Let me highlight in yellow here what our original function is. that function has a square root, and we can only take the square root of a number that is greater than or equal to 0. So that's going to be our restriction. We're going to have to require that 2x minus 4, which is inside our square root, has to be greater than or equal to 0. Now let's solve for x. We have 2x greater than or equal to 4, which is x is greater than or equal to 2. So we can say that our domain of f of x, which is our range of f inverse of x, is all numbers 2 to infinity. And we did it. Before I end this video, I want to show you the graph. So here's our graph. This is our graph of our function y is our inverse, and our inverse function is x squared plus 4 divided by 2 with the restriction that x is greater than or equal to 0. This is what our graph looks like. Notice that x is going to be 0 or greater than 0, and that's our domain right here. And then notice that our function itself starts at 2 and continues on to infinity, so that's our range from 2 to infinity. Now that you've seen these 3 examples, you should be able to solve these types of problems on your own. In the next video in this series, I'll show you how to determine if a function has an inverse.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.